Hi friends, in this session of correlation analysis, we study about the Spearman's rank correlation coefficient. This method of finding out the coefficient of correlation was developed by Charles Edward Spearman. So first I would like to explain why we use this rank correlation coefficient, why it is important, what are the utilities of this. So when it is known that the population is not normal, or when the shape of the distribution is not known, there is a need for measure of correlation that involves no assumptions about the parameter of the population. What about the parameters, the mean and the standard deviation? It is possible to avoid making any assumptions about the populations being studied by ranking the observation according to size and basing the calculations on the ranks rather than upon the original observation. This method of finding out of correlability or the lack of it between two variables was developed by the British psychologist Charles Edward Spearman in 1904. So here first I would like to explain the formula what we use for this. Here we use two sort of formula here. Number one is if the observations or ranks are not same. If the two observations or ranks are not same, they are all different ranks and the different observations we have. So we use this formula. So we get the Spearman's rank correlation coefficient, which we denote here by RS, is equal to 1 minus 6 into summation of d square over n cube minus n. Now let I explain you here. Where RS denotes rank coefficient of correlation and D refers the difference of rank between paired items in two series, and n is number of total observations. So here you see in second formula, if two or more observations or ranks are same, then we use this formula. RS is equal to 1 minus 6 summation of d square plus 1 by 12 of m cube minus n plus 1 by 12 of m cube minus n plus and so on. So here n is number of equal observations. If we have two same observations, we will put here 2 cube minus 2. If we have somewhere in the other series or the same series we have 3 observations which are same, so we could write here 3 cube minus 3. So in this way we have to write up to the equal observations we have. So I will explain you these all things with an example. First we study about where the observations or ranks are not same. We see one tutor type example here. Look at here. In this example, calculate Spearman's coefficient of correlation between marks assigned to 10 students by judges X and Y in certain test is shown below. So look at here, we have the serial number 1 to 10 here, and the marks of judge X given to the students in this way, and the marks of judge Y is given in this way. So this table has been given to us in a question. So we start with the solution like this. So we use the solution, first assign ranks and then calculate rank correlation coefficient. So first we assign the rank, or we could give the rank the biggest or the largest one rank first, and then we go in the decreasing order, rank 2, 3, or we could also give the rank to the smallest one first rank, and then we go through the increasing or the ascending order. We could give the ranks. So there is no hard and fast rule how you approach this ranking technique. Now we make 6 column table here. The first column we use for marks by judge X, we will write here, and the second column we have to write down the rank, corresponding ranks we will give to these marks, and third column you see marks by judge Y, the other variable is given to us, we have to use third column, and in the fourth column we have to give the corresponding ranks to these marks, and the fifth column we use the difference of the ranks, Rx minus Ry, we have to find out the difference, and then the sixth column we have to find out the square of this difference, and we have to find out the summation of this difference also. Now look at here, in the marks by judge X is given in 2 digits. So the smallest 2-digit number we see here, we have in the tens place of 2-digit number is 2. The smallest digit in the tens place is 2. So we have 2 numbers here for having the 10th digit 2, 25 and 27. So we give the rank 25 first, the smallest one, and the second 227. 10th digit we have 3 in 2 numbers only, 37 and 38. So this we give to third rank, and this is the fourth rank. In this way, this one is our 5th rank, 6th rank, 7th rank, then 8th rank, 9th rank and 10th rank. In this way we have to give the rank to the numbers observations. Here in the marks by judge Y, we give the rank. In this way we have the 2 tens place, we have 2 here on 25, so we give rank 1. After 25, 30 and 32, so we give it 2, give it 3, 32, then 38 is 4 rank, then 38, after 38 we have 43, 48, so 43 we give 5, and 48 6, and we have 50, so it is our 7th rank. After 50 we have 65, we will give it 8th rank, and 68 9th rank, and 77 10th rank. So in this way we have given the rank to the observations in ascending order. The smallest one we have given the first rank, then 2, and then 3, in this way in both the variables x and y. Now we have to find out the difference between both the ranks. D is equal to Rx minus Ry. So here you see it is our Rx and this is our Ry. So we do it. 8 minus 8 is equal to 0. 9 minus 9 is equal to 0. 6 minus 5 is equal to 1. 10 minus 4 is equal to 6. 7 minus 10 is equal to minus 3. And 5 minus 6 is equal to minus 1. Here 3 minus 2 is equal to 1. 4 minus 3 is equal to 1. 1 minus 1 is equal to 0. And 2 minus 7 is equal to minus 5. So this we have got the difference of the ranks. Now we have to find out the square of the this difference. So 0 square is 0. Here also 0. Square of 1 is 1. Square of 6 is 36. Square of minus 3 is 9. Square of minus 1 is 1. 1 is 1, 1, 0, and square of minus 5 is 25. So what we have to find out here? So now we find out sigma d square. But now we get the summation of d square. So 0, 0, 1, 1 plus 36, 37, 37 plus 9, 46, 47, 48, 49, 49 and 25, so which is 74. So we have 74 here, the summation of this. So we have this summation. Now we know the formula, because we know that RH is equal to 1 minus 6 summation of d square over n cube minus n. So we will write down the values here. R is equal to 1 minus 6 into summation of d square, we have 74. We will write down here 74, and we have 10. The total number of observations we have 10. Here you look at here, this is the 10 observations we have, 1 to 10. So we have to write down here 10. 10 cube minus 10. So it is 1 minus 6 4 times, 24 2 carries, 6 7 times 42, and 2 44 over 10 cube 1000 minus 10 is equal to 1 minus 444 over 990. So we get here 444 over 990, 0.448, 0.448. So we could write in this way. We will take only 2 places after decimal. So we get here 0.45. We subtract it from 1. So we get here 0.55. So it is 0.5. So it is the R is the rank correlation coefficient. We have got here 0.55, which is positive. We mentioned the positive, or it is also between minus 1 and 1. It's always between minus 1 and 1. So this is our answer for this. Thank you.